welcome to True Projects. In this video, we are going to explain about a project titled Ocean Wave Height Prediction. The innovative project focused on creating an advanced system with the ability to precisely predict the ocean wave heights. By harnessing the power of state-of-art machine learning algorithms and extensive historical wave data, the project aims to complex patterns and influential factors affecting the wave height. The main goal is to construct a reliable predictive model capable of generating the real-time forecast of ocean wave height. The significance of such system extends to various domains including the marine industry, coastal community, and the marine safety measures. With improved preparedness for the wave-related events and enhanced navigational safety at sea, this project promises to have a positive impact on the critical decision-making process and the risk mitigation strategies. The primary goal of this project is to develop an advanced and comprehensive ocean wave height prediction system by leveraging the cutting-edge machine learning algorithms such as long short-term memory, supervector mission, and the gradient boosting. By analyzing the historical ocean wave data, the project aimed to train this algorithm to effectively capture the intricate temporal relationship, non-linear pattern, and the interconnected factors influencing the wave height by combining the strength of the LSTM, SVM, and the gradient boosting. The project is to create a robust and precise prediction model. The anticipated outcome of the system hold the immense potential and significantly improving the wave height forecasting capability, benefiting the maritime industry, coastal planning, and the marine safety features, thus empowering the stakeholders with valuable insight for the informed decision making and enhanced the risk mitigation strategies. These are the basic requirements that are needed to build this project. The software requirements: Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. And the step essential Python libraries like TensorFlow, sklearn, Pandas, and NumPy are imported. TensorFlow is used for building and training the deep learning model like LSTM, sklearn for SVM and the gradient boosting, Pandas for data manipulation, and NumPy for numerical computation. And the second one is importing the dataset. The dataset contains the ocean wave data, including the attributes like significant wave height, maximum wave height, zero crossing period, peak wave direction, and sea surface temperature is imported. This dataset serves as an input for training and testing the prediction model. And the third one is data visualization. The imported dataset is visually explored using the plot and graph to gain the insight into the relationship between the various wave parameters and identify the potential pattern or the trends. And the fourth one is building the model. Here, various machine learning models are built, and the first one is of LSTM. It stands for the long short-term memory. It is a deep learning architecture specifically designed to handle the sequential data, making it ideal for the time series analysis, such as ocean wave height prediction. It excels in capturing the long-term dependency and patterns and the time series data, crucial for understanding the temporal variation and the wave height. LSTM ability to retain and update the information over the long time interval, mitigate the vanishing gradient problem, and ensure the efficient learning from this historical wave height time series. By leveraging the LSTM, the project aimed to build a powerful predictive model capable of accurately forecasting the future wave height based on the past observation. And the second one is SVM. It stands for Support Vector Mission. It's a versatile supervised learning algorithm that has found the application and both the classification and the regression tasks. And this project, the SVM, is utilized for wave height prediction. Treating it as a regression problem, SVM seeks to find an optimal hyperplane that best separates the data point representing the different wave height. Its ability to handle both the linear and the non-linear relationship between the input features and the wave height makes it well suited for capturing the complex pattern in the dataset. By employing the SVM, the project endeavors to create a reliable and accurate regression model for predicting the ocean wave heights, providing the valuable insight into the potential wave event. And the third one is gradient boosting. Gradient boosting is an ensemble learning technique that combines the multiple weak learners, typically the decision tree, to create a robust and accurate predictive model. During the training process, weak learners are sequentially added with each new learner, focusing on correcting the errors made by its predecessors. This repetitive approach enables the gradient boosting to progressively improve the prediction accuracy and capture the intricate relationship between the input features and the wave heights. By utilizing the gradient boosting, the project aimed to create a powerful ensemble model that leverages the strength of the individual decision tree to achieve the higher accuracy and the robustness and the ocean wave height prediction, enhancing the overall forecasting capability of the system. And next step is training the model. The LSTM, SVM, and the gradient boosting models are trained using the historical ocean wave data. During the training, the model learns from the relationship between the date or time and the wave parameter to predict the future wave height. And the next step is user gives the input. A user-friendly web interface is developed using the Flask, allowing the user to input the date or time and other wave parameters for the wave height prediction. And the next step is the given input is pre-processed for prediction. The user provided input is pre-processed and transformed into a format compatible with the trained model. This step ensures that the input data is properly aligned with the model's requirement. And the next step is trained model is used for the prediction. The pre-processed input is passed through the trained LSTM, SVM, and the gradient boosting model. Each model generates the prediction for the ocean wave height based on the provided parameters. And the last one is final outcome is displayed. The prediction from the LSTM, SVM, and the gradient boosting are combined, and the final outcome, which include the predicted ocean wave height, is displayed to the user through the web application. This enables the user to assess the real-time or the future wave height forecast, crucial for the maritime activity, coastal planning, and the marine safety measures. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the various folders like of CSS, JavaScript, images, and icons within it. And the template folder containing of the HTML documents like of home, index, notebook, results, sign in and sign up pages within it. And the app is an py file which likely contains the algorithm information that related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the dataset is the used in this project as in the form of CSV file, and the model is an H5 pickle file which contains the information of algorithm, and it can load it into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which likely contains the information and the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And to execute the project, first we need to copy this code folder path and then open the Anaconda prompt. And here we need to change the location of the disk to F. Because our code folder is present in fdisk, then write a command that is cd space and paste this code folder path. By this, it will change the current directory to the code folder path, and then write a command that is python space app.py. By using this command, it will execute the Python script and check the runtime errors and the syntax errors and the logical issues within it. After running this app.py file, the Flash framework will host an local default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am pasting this link and then click on the enter button. By this, it will redirect you to the page where it contains the title of the project and the sign up and sign in buttons. And here, clicking the sign up button, here it will redirect you to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I am using the sign in button. Here it will redirect to the sign in page containing of some details like username and password that are need to be filled to be logged in. And I am entering the details of username and password as of admin, and then click on the submit button. I'm clicking on the submit button. It will redirect to the index page containing of some necessary details that are need to be filled to predict the ocean wave height. And here I'm entering the maximum wave height in the record as of 19.5, and the zero upcrossing wave period is of 6.7, and the peak energy wave period is of 8.7, and the peak direction is of 107, and approximation of sea surface temperature is of 32.3, and then click on the predict button. Here it redirects to the result page and it giving the significant wave height of 2.246, and this way we can predict the ocean wave height by using the different machine learning algorithms. And in conclusion, the project has achieved its objective of developing a state-of-art prediction system leveraging the power of advanced machine learning algorithms including LSTM, SVM, and the gradient boosting. The project has successfully forecasted the ocean wave heights with remarkable accuracy. This predictive model offers the valuable insight into the wave behavior, aiding the maritime industries, coastal communities, and the marine safety efforts. The project's outcome have paved the way for the better preparedness and the wave-related events, improved navigation safety at the sea, and enhanced planning for the coastal activities. Overall, this project represents a significant advancement in the field of ocean wave prediction, contributing to safer marine operation and the coastal resilience.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.